Hello and welcome to the 11th video in this series of videos on Program HS Engine in C. So now we've finished looking at some of the clearing and setting bits and those various things to do with the pawn structure. The next thing I want to look at in the position is the hash key. You remember somewhere inside our position structure here we have something called the position key, normally called the hash key, and I've decided here to make it called pos key, position key. And you remember I said in either the first, second, third, I can't remember exactly which video, that this key basically will be a unique number representing the position on the board, and that will be used to detect, using this history array, whether we have any repetitions in position. So what we have to do is we have to program in some way of actually generating this unique key for the position on the chessboard. I've added a file called hashkeys.c to the project, and I've also added it into the make file, but we won't actually be, apart from including defs.h, we won't actually be, I'll just change that, we won't actually be using any code in this file in this video. I'll be doing it in the next video. I just want to show inside our main function in vice.c how, I'll give a little bit of an idea how this position key, unique key, is going to work. So I've got include here, and I'm including the standard library because I'm going to be using the rand function. And I'm going to declare very quickly some variables. I'm going to use my imagination and call them piece 1 and set it to a random number. And you can probably guess that it's going to be 2, 3 and 4. And each of these are random numbers. So the first thing I want to do is actually print these to the screen, just so that we know what values they are. And I'm going to use a capital X because I want to print them in hexadecimal format, and print a new line, because when you're looking at position keys it's easier to look at them in hexadecimal format because of the letters and the numbers, particularly when using 64-bit integers, although for this example here obviously we're sticking just with the plain old integers. The first thing I'm going to do very quickly is copy and paste this in 3 more times and quickly get these printing. Okay, so the next thing I want to do is I want to make another variable, and we'll call this the key. And the way you generate your key is you take all the pieces on the board and you exclusive OR the values of them together. So not the values of the piece, like I think a white pawn actually has a value of 1. Each piece will be given, using an array index, a random value, and you XOR these random values together to get you a complete individual key for representing all of those pieces on the particular squares they're on. So you XOR them together, it's called exclusive OR. And if you don't understand how exclusive OR works, then please have a quick Google and look at it, or I'll be covering it shortly in one of the C tutorial videos. I've just finished covering and OR in bitwise operations, and I'll be getting around shortly to the exclusive OR, but it's done by exclusive OR. So the way I do that is simply to have piece 1 exclusive ORed with piece 2, with piece 3 and piece 4. I'll just quickly paste in the correct variables here in this manner. And now let's do something else before I start printing and actually running the program to the screen. Running the program to the screen. Let's make something called a temp key, temporary key, and let's generate the key another way so you can start getting an idea of how this works. Well, first of all, set temp key equal to piece 1, and then what we'll do, we'll XOR temp key with, let's say, piece 3. We'll XOR it with piece 4, and we'll also then XOR it with piece 2. And if you're not familiar with XORing, then you might be quite surprised to learn that both these values will end up exactly the same. If you are familiar with it, then you won't be surprised at all. It'll already be pretty clear what's going on here and how we're using this method to generate a consistent key for each position on the board. So now I'll just print key to the board, to the screen, and I'm going to print temp key to the screen so you can see what they look like. So I'll just run back to make, hit compiled, good. And where's Vice? There it is, and run it. And now let's have a look. So we've got 29, 4823, remember it's hexadecimal, 18BE, and 6784, our random numbers. And key, with those four numbers all XORed together at once, turns out at 3730. And temp key, where we started with piece 1 and XORed in piece 3, then piece 4, then piece 2, also gave 3730. And in fact, if I go back to the program, and let's say I put piece 1 on the end and actually start with piece 2 and compile the program and run it, I get exactly the same result again. So hopefully you can see how you can use XOR to maintain a consistent key for the position. So for example, I could say, let's say we know that temp key at the moment represents the position with all four pieces, as does key. But let's say we generated key without piece 3. So the position has piece 1, piece 2 and piece 4 in it. Now temp key at the moment is the key for all four pieces together. So to take piece 3 out, all you do is simply XOR again with piece 3 to take it out. So if I print 3 out and temp key, and then let's put piece 3 in again and see what the value of temp key is. And this should be the final thing that should make it sit in the brain of what's going on. So temp key is 3730, but we can see that key, our unique key, without piece 3 is 2F8E. So we take 3 back out just by XORing piece 3, and now you can see we have 2F8E. Now if we put 3 in again, we end up with the 3730. So that allows us this method, and what we'll be doing in the next video in the chess program, is to use a similar method to generate a unique key for the position. Okay, so I hope that's clear. Play around with the XORing if it's not clear to see what the keys are like, or ask a question in the comments section. Otherwise, thanks very much for listening. Comments, questions, criticisms welcome as always, and see you in the next video.